Okay. Oh, that's funny. Alright, so hopefully that worked. We'll see what happens. Oh man. Alright, so let's go do this lesson. Let's get this out of the way here. Am I allowed a chat? I don't think there is one. Okay. Alright, well, I'm going to start recording. Alright, so welcome to Rationalizing Rational Functions. This is the stream you want to be with, and on your NTI day. I hope you got some extra sleep today. But we are in the middle of rationalizing, rational functions, and today we're looking at complex functions and rational functions and how they, I guess, just interact with what we've already talked about. So on screen you can see the content on the quiz. I did break it up into the larger categories on purpose. I know that category 3 with the features of rational functions is pretty intimidating, but it's really a lot more definitions in that and less math. It's a lot of knowing where to look in the function instead of relying on a lot of algebra to get you there. Of course, there's factoring and some things that are important in that section, but this section is mostly what we've gone over in the past 2 classes, and there's some videos posted about that. The first 2 are going to be a bit older, at least in our unit progression. They were the first things we did, and we're actually revisiting that today, and we're adding a little bit more to it. So you'll be asked to complete the even questions for this practice. This is the practice I'm posting on Classroom, and it has one of them already completed, and I'm going to take you through what happens here. Hopefully I remember the upload process, or this one is not going to be on on YouTube, but maybe it will be. You'll just have to skip through the boring parts where I'm figuring out how to work a stream. So anyway, the work for complex fractions, which is what these are when there's fractions inside of fractions, works like this, which is to say we're always going to work down in these fractions. I know it looks like sideways, but if you follow the steps, I'm always working down so I'm not losing the fractions from side to side. Things can get pretty polluted if you're not going to a new line. So like the lines on your paper should help. Of course, there's no lines on this one. The idea is we're going to work with just one side of the fraction at a time. So this side, obviously there's nothing to do with 9, and we'll find a common denominator for it, which is 6, and that was done by giving this left fraction a 3 over 3 and the other one a 2 over 2, and then we add them, and then we keep change flip. So we keep the 9 in the numerator, flip the other fraction with the multiplication symbol in between, and then we multiply the numerator, and that's going to be your path through for number 2 and then subsequent ones. The next ones do follow I guess a bit more steps. There are some more steps to complete with these, so we'll go ahead and we'll do this one together. Our number 3 has us give a common, well, I guess we're going to work on the numerator first. We can work one at a time, but we're going to need a common denominator of x plus 3 in order to add these together. So you have to pardon my clicks if you can hear them. But yeah, we can work with this side and we can add that together. And then I'm actually going to I'll pause this here. Well, I'll pause writing on the bottom just yet. I'll use a different color, and I'll just add that's a 3, my numerator together with its new common denominator, and there we have the numerator set as one fraction, which is really our goal. We want to find a one fraction over one fraction. In other words, this like a over b over which is what this 9 is, the 9 over 1 over a c over d, which is this 9 plus 2x squared over 6, so that we can go into this step, which is keep change flip. Otherwise, this, there's too many layers to peel back here. So there's that. We have our a over b, I guess. Now we need our c over d. And I'm going to use a different color. So let's try, hello. Let's try adjusting that real quick. We are going to not give this left-hand fraction anything because it already has x plus 3. But this one needs this right side, it needs a 4 times x plus 3. And some of you all might be like, I kind of knew what this was a while ago because I know what's going to happen, Mr. Troy, with this x plus 3 in the bottom. And that's great. I want to show that you don't need to have that shortcut necessarily. But yeah, you can see that now we have our b and d the same value, x plus 3. Of course, x plus 3 is elsewhere, but we can't access those because this is all one quantity. Well, what we can do when we keep change flip, right, is these will cancel, the denominators, and then we'll be left with this 3x plus 3 minus 2, and then times, remember from keep change flip, this 1 over x plus 4, x plus 3, because our x plus 3 is canceled. So right, we can really just write that as the singular fraction. If I can erase. Right. So our quantity here, we can distribute some things. We can make it a little bit tidier, but it's not going to be, what is that, 9 minus 2, so 7. It's not going to be any better to simplify. Where we're getting 5x plus 12. So there's no common factors. This is as best as it gets. Right, so there are some excluded values, which we can see from both forms. X can't be this negative 3, but also x can't be negative 12 over 5. So yeah, you've got this key at the bottom too. So there was our answer. There was our first answer, which you can use to your advantage. The next one, 5, I'm gonna leave alone. It's a lot of the same. I guess I can begin that if you'd like, but maybe if you all show up and want to talk later, then we can go over one like that, because there's similar ones like it that you might have to deal with. But I really want to talk about rationalizing these fractions, and to do that, I'm gonna separate some space here just a little bit, and that's to say, if you were asked to rationalize 1 over square root 2, for example, which is to say, we want to be able to divide by a whole number, really a number that doesn't repeat itself indefinitely, and radical 2 just doesn't work for that. It does repeat indefinitely, so we can rationalize this value by multiplying by square root 2 or square root 2. This gives us square root 2 over square root 4, because multiplying radicals multiplies just their I guess their arguments, so 2 and 2, and this is square root 2 over 2. The same will work if I put x there instead of 2. We'll get square root x over x. So the issue, though, is with these binomial ones. So we have a binomial denominator for number 8, and I think I'm asking you to complete the even. So I'm going to leave this one here and go work on a tougher one, but I'll just describe it here. We are multiplying by a conjugate to undo this square root x minus 3. And I'll put some info over here as well. So remember, when you have a conjugate, a minus b, well, that in itself is not a conjugate, but the conjugate to a minus b is a plus b. When these are multiplied, we get a difference of squares. So in a situation where we don't want a radical, we can force it away by saying, well, if I find the conjugate, x plus 3, and foil or distribute all this through, and I have to do it to the numerator also, then my result will not be a radical. I won't have a radical in my my fraction anymore, which is the whole goal of rationalizing. So you can see what this answer is meant to be. You shouldn't have any radicals in your denominator, but it doesn't mean you're not allowed to have them in your numerator. So like your numerator, 2 square root x plus 6, that's okay. But I'll leave that one there. Let you connect it with the answer below. Number 9, if I can go there. Yeah, it's all good on stream. Oh my gosh, I think I have a viewer. Hi viewer, I don't know who you are, but this 2x plus 5 over 2 minus square root x minus 2. Again, we're just finding the conjugate to 2 minus square root x minus 2. And we're multiplying that through, so I don't know why I put equal signs there. But we're going to multiply by 2 plus square root x minus 2. So it's only, remember with conjugates, it's only the sign in between the two numbers. And when we multiply our denominator out, we can use the shortcut of, let me make sure I'm showing the conjugate there. But over here, I don't have a great pointer, but over here, having the difference of squares equaling the a minus b, a plus b, this will be a shortcut for us to writing this and not multiplying it out all the time. That's what I'm trying to say. But I'm going to do it for this first one so that you can see if you're lost, that foiling still works. The numerator is going to be maybe the most annoying part of this, because that all can be foiled. Can distribute everything. So 2 distributed to 2x plus 5 looks like that. And then plus 2x square root x minus 2 plus 5 square root x minus 2 looks like this. Numerator looks really pretty. And then the a minus b, a plus b, we know will multiply to be a squared minus b squared. So 4 minus b is square root x minus 2, but then that's squared, so then that's just x minus 2. But I'm going to leave it as a quantity. It needs to stay as a quantity with parentheses so that I don't misplace a negative. So let's go look and see what the answer key has. Make sure we're on track here, as pretty as this is. Yeah, so looks like we're going to get our 6 minus x, the 2x plus 5. Right. The answer key just has the two values multiplied. And yeah, we do get 6 minus x as our denominator. So yeah, I'm fine with that. I wasn't sure how that key was laying out the answer, because and I really like this too, because I hope you all could all assign numbers in FOIL and distribute okay. It's really this denominator that we're looking to simplify, because there's some really simple operations there, and we want to be able to tell what numbers are we allowed and not allowed to place into this fraction. So this will come in more handy as we talk a little bit about our difference quotient and working with limits with that as well. So rationalizing, I'll do one more, and then I'll call it. I'll see if I can post this stream. Dang, let me see if I go into this. Oh, just real quick. Yeah, it's a. The echoes is killing me. Yeah, I don't know if the like streams on JCPS can be like posted, but I know that the viewers can't really interact. So I was gonna see if there's a way to get questions, but that's all right. So anyway, this is the last one that I'm gonna complete. So right, if you find the conjugate, it's a pretty simple process. So multiplying that through, again, your a minus b, a plus b. When they multiply, you'll get your a squared minus b squared. Yeah, I'm fine with leaving the numerator as just a binomial times another less manageable binomial, but still one that is, it's okay if those square roots are in the numerator. They can stay up there. Our m minus 5 is going to result from multiplying our two a's together, and then minus 5m, square root of 5m squared will be just 5m, and we're done. So it's not anything too wild. It seems like it's the craziest expression you've ever seen. Honestly, the ones at the top will probably be a little trickier because there's adding and subtracting and multiplying and dividing to do. So these are really just a formality. I hope you see them that way. It makes completing what looks like strenuous tasks, and I'm just going to rewrite this one because I don't want to rewrite this with my mouse. Makes completing strenuous expressions like this look pretty easy. So what we're going to get m minus 5m minus 5. Okay, so negative, so we could put it, there's just not a nice way to put this one, but that's going to be negative 4m minus 5 as your denominator. Yay. Okay, so yeah, negative 4m minus 5. The work you see, and I guess for the one person who's here, I'll reiterate. The content on the quiz on rational functions, again, is going to be like this. So I said this at the beginning of the recording, but our three, I guess, larger topics are meant to divide the quiz pretty nicely. It looks like there's a lot to do for topic 3, and I guess there is, but it's not going to be as important as making sure you have all 3 of these evenly distributed in your studies. So that quiz is on Thursday, and again, like the third bullet point there, identify features of rational functions. It's pretty extensive, but it's mostly vocabulary. The other 2, they're much more algebra heavy. You can place this lesson that we just talked about in the simplify rational expressions category. The solving rational equations, it's kind of lumped into that first one, and maybe you can say there's 2 halves to this thing, this quiz, but yeah, I would just look back at the most recent stuff on Classroom with the videos. I'm going to post this one hopefully, but otherwise I'm going to get off. I need to go feed my children breakfast and I don't know, shovel snow, I guess. I'm sure they want to go play. So I'm going to get off. So thanks for viewing, my one viewer, and I will see you guys soon. Bye.